write down two criteria for ductile material. And today we, if you missed the lecture last time, you can go to YouTube. I think we have the video there. And today we're going to do the criteria for ductile, for brittle materials. And for brittle materials, we have one. We have two. One is called the maximum, the normal stress criteria. And if you remember, compared to the ductile, we have, for the ductile material, first one we have is called the maximum shrink stress. Because usually for ductile material is kind of weaker in taking the shearing, compared to the brittle material is weaker in taking normal. Okay, those are the built up by empirical observation first, and then they verified by experiments. So for this one, that is pretty easy. Let me draw the curve first. So this is a sigma 1, sigma 2, the normal stress, the principal stresses. And if we have the material, so say this is the material under uniaxial loading, and under uniaxial loading you just pull it up until this one gets broken. Okay, at that moment we denote the in terms of our material testing, this is stress, this is strain. For brittle material is the curve is like this. There is not so, for ductile material it would have certain like this one. It has a very clear cut about the elasticity. But for ductile, it's for brittle. But for brittle material, if you do the testing, then the curve is pretty much like this. Okay, and here we call the maximum, the maximum stress will be corresponding to is where it's broken. So here we call the U, the sigma U. Sigma U corresponding to is the maximum stress, the material will get fractured or broken. Okay, so that's the material properties. And for this case, it's under tension, so we denote as the optimal stress. The U means optimal, the ultimate stress. And for this case, it's under tension, so we call the UT. So under testing, if we continuously compress this material and get the crack be developed, the corresponding is called the UC. Optimal stress that cause the cracking due to compression called the UC. So we have those information here, then we simply put into here. So that is the U sigma UT, positive sigma UT, and then sigma UC, which is negative sigma UC. So for this criteria, that is pretty straightforward. That the boundary edge is connected the 4 points by basically that is square. Okay. So any if your loading condition is falling into this boundary, then that is safe. In mathematics, this is described by this: the sigma 1 or sigma 2. The magnitude is less than or equal to sigma UC, and the second one is sigma U1 or sigma U2, sigma 2 less than or sigma UT. Okay, so that meaning as long as the absolute value is falling into the range, then that should be safe. And this criteria is very straightforward, and we might have example here, but compared to this criteria, we have the second one. It's called the Moore's criteria. And again, here we are given, we consider a material, and the UT and sigma UC are the properties, material properties of that material. So that should be able to get it from any data manuals here. So we have this one. This criteria saying is this. Build up upon the Moore circle, so that means here we're going to use the Moore circle. That means here Moore circle, this is the no stress, this is the strain stress. So we're going to draw a few more circles, and using those more circles to build up the envelope of the safe regions. And that one being built up is this one. And again, once we have given the material properties, we simply label those material properties here. So this is sigma UT and positive, sigma UC, which usually is negative. Okay, and that definitely that is negative, the compressor stress. And for this case here, we build up the Moore circle. For this one, simply we using the 0 and this one to draw a circle, and let me try to draw it in a good way. Okay, so that is a circle with the diameter from 0 to here, and we'll put a circle here. And in a similar way, we use the diameter from 0 from the origin to the UC, and corresponding circle is this. Okay. So for this circle, that corresponding to the condition is, for this scenario, for this one, basically let me draw it here, that is corresponding to material is under pure compression. So all this scenario, all this kind of scenario will fall into this kind of circle. And depends on the loading, so your loading condition would get into the point which might be inside the circle or outside. If inside the circle, then that loading will means that it's safe. If the loading conditions is falling outside of the circle, then basically, per this criteria, we say that is unsafe. In a similar way, for this circle, that's corresponding to is the loading is under tension. Okay, in a similar fashion. So now the two circles basically take care of the two scenarios. And for the two scenarios, basically all the stresses have the same sign. For this case, is all these principal stresses will be the positive, and this will be all negative. And how about for the situations if one principal stress is say positive, one principal stress is negative? So that means for this scenario, then you can imagine the circle could be in between. So that means here for this one, we have additional information to build it up, and that information basically described is this. Okay, so this let me call the scenario 1. Scenario 2. And 3. So that means when principal stresses have opposite